Okay, so you got your test back. Good job on that extra credit, by the way. Today we're going to start Unit 3. And what we're going to start out with today is we're going to start out with dealing with powers of 10. We've seen, something like this before. What does that mean? 8 to the third power. And how would we calculate it? 8 times 8 times 8. Yes, 3 8s multiplied together. And if you do that on your calculator, it's 512. You guys know where the power key is on your calculator? Okay. So I'm going to have you erase me on one. 5 to the power of 6. Nice try. How about 2 to the power of 12? Good job. Okay. How about 10 to the power of 5? 100,000. 10 to the power of 3? 1,000. 10 to the power of 7? 10 million. Now, exactly. Whatever this power is, that's how many zeros there are behind it when it's a power of 10. So then how about, what would 10 to the power of 0? Don't punch this one in quite yet. 1. Okay, why is it 1?
Because I remember it from algebra in high school, but I don't remember why.
Okay, anything to the power of 0 is 1. The question becomes, why? Just like when we were multiplying our negatives, when you multiplied two negatives, the definition of multiplication doesn't fit. Well, power of 0 doesn't fit our definition of a power either. So just like with the negatives, we're going to look for a pattern. 10 to the power of 5. We said it was 100,000. 10 to the power of 4 is 10,000. What's 10 to the power of 3? 1,000. 10 to the power of 2? 100. Now let's take a look here. When we have an exponent with a base of 10, that's the base, when the power is reduced by 1, so it goes from 5 down to 4, what happens to the result? Divide by 10, yeah. Loses a 0 or divided by 10. Goes from 4 down to 3, you divide it by 10. So that fits, right? So if we keep going from 2 down to 1, what's this result? What's 10 to the 1? 10. Did that go divided by 10 again? Yes, it did. So that pattern works. So we're going to assume that pattern continues. 10 to the 0, well, what's 10 divided by 10? 1. In fact, we can keep going. 10 to the negative 1, what's 1 divided by 10? 1/10. 10 to the negative 2, what's 1/10 divided by 10? 1/100th. 10 to the negative 3, 1/1000th. 10 to the negative 4, 1/10,000. Well, because we're dividing by 10. 1 divided by 10 is 1/10. 1/10 divided by 10 is going to be 1/100th. Basically, what you see here, 10 to the 4th is 10,000. 10 to the negative 4th is 1 over 10,000. The reciprocals.
How would you punch that into the calculator? 10 divided by 10 divided by 10.
10 to the power negative 4. Now, this is giving me scientific notation, which we're going to talk about later. That's 1e negative 4 is saying you take your decimal point here, that's after the 1, and the negative 4 means you have to move it over 4 spots, which is the 10,000ths place. So the negative powers are not the number of zeros, the negative powers are the number of decimal places. So 10 to the negative 4, that 1 is in the 4th decimal place. What if I have 10 to the third times 10 to the fifth? And no, I don't want this written out with all the zeros. I want to keep it as 10 to a power. Well, yeah, 10 to the third is 3 tens multiplied together. 10 to the fifth is 5 tens multiplied together. And if I multiply those all together, I have now 8 tens multiplied together. So that is 10 to the 8th. So if I have 10 to the 12th times 10 to the 15th, I'm going to get 10 to the 27th. Very good. How about ten to the fifth divided by 10 squared? Very good. 10 to the fifth is 5 tens multiplied together. 10 to the second is 2 of them. And in fractions, we can cancel out common factors. We can cancel out a 10, cancel out another 10. Leaves us with 3 tens up there, or 10 to the third. The shortcut, of course, was to do what to the powers? Subtract them. 5 minus 2 is 3, so 10 to the third. So if I have 10 to the 20th, divided by 10 to the 12th, I get 10 to the 8th. 10 to the 17th, divided by 10 to the third, I get 10 to the 14th. 10 to the 5th, divided by 10 to the 12th, 10 to the negative 7th. Right? 5 minus 12 is negative 7. 10 to the negative 3rd, divided by 10 to the 7th. 10 to the negative 10, yes. Negative 3 minus 7 is negative 3 plus a negative 7, which is negative 10. That new projector is really bright, isn't it? Kind of like it. Okay. So what if I had 10 to the 5th times 10 to the negative 9th? When I'm multiplying, I do what with the powers again? Add them. So 5 plus negative 9 is negative 4. 10 to the negative 7th times 10 to the negative 5th. 10 to the negative 12. Good. So what would we do with something like this? So I do the top first, right? The fraction bar means I have to do everything on top first. 10 to the 8th times 10 to the 5th is 10 to the 13th. I do everything on bottom. 10 to the 7th times 10 to the 3rd. 10 to the 10th. Then I do the division. 10 to the 13th divided by 10 to the 10th. 10 to the 3rd. Good. So here I'm adding the powers. And here. And here I'm subtracting the powers to get the 3. So what if I had something like this? This here is going to be what? 10 to the negative 7. And this is going to be 10 to the 8th. So yeah, negative 7 plus 8 is 1. So 10 to the 1 is just 10. How about something like that? Yep. How many 10s are there? 12 total. So it's 3 times the 4. when you have an exponent raised to another power, you multiply the powers. So 10 to the 7th to the power of 10 is 10 to the 70th. 10 to the negative 5th to the power of 4, 10 to the negative 20th. 10 to the negative 8th to the power of negative 6. 10 to the 48th. So let's play with that a little bit more. So here's something like this. 10 to the 7th divided by 10 to the 18th has to happen first. What's that going to be? What are we doing with the powers? Adding, subtracting, or multiplying? Subtracting. 7 minus 18. Negative 1 says 10 to the negative 11. Then 10 to the negative 11 to the third power. Negative 33rd. Where do I start here? Obviously in the parentheses. 10 to the negative 7th times 10 to the 13th is going to be 10 to the what? 6th. 10 to the 6th to the negative 5th power. 10 to the negative 30. Very good. Where would I start here? Negative 8. 10 to the negative 8 times 10 to the third is 10 to the 5th. Negative 5th, yes. Negative 8 plus 3. Down bottom. So, yeah, 10. Yep, 10 to the 7th times 10 to the negative 20 is 7 plus negative 20 is negative 13. Careful. So 10 to the negative 5th divided by 10 to the negative 13th. Negative 5 minus 13 is negative 5 minus negative 13 is negative 5 plus 13. Negative 5 plus 13 is 8. It's 10 to the 8th. 10 to the 8th to the 5th. Good stuff. Better than sharp stick in the eye. Maybe he hesitated a bit there. About once every 2 years, I run a construction company that size. About once every 2 years, I'll get a piece of sawdust in my eye, and it'll scratch to the point where there's nothing you can do. I mean, you can't even concentrate. It hurts so bad. So I have to go. I literally, all I can do is, because even once you get it out, your eye is scratched to where you can't do. So you have to go lay down and like sleep for about 2 hours and wait for your eye to just recover. Not pleasant. So tell me what to do here. So 10 to the 4th divided by 10 to the 15th. So 4 divided by, or 4 minus 15 is 10 to the negative 11. Negative 5 plus 11 is 16. Because we're multiplying, we add. Then what? So So 10 to the negative 11 divided by 10 to the 6 is negative 11 minus 6. Okay, and then yeah, 10 to the negative 17 to the power of negative 3. We're going to do negative 17 times negative 3, positive 51. Yes, it is. We'll have some fun ones of those to do later. So now that we've got these powers of 10, there's something very important we need to look at. We need to go back to our place values. Remember, we talked about these place values. You know, this is the ones, tens, hundreds. And I'm just going to write them out numerically. 1,000s, 10,000s, and so on. This is the 1/10ths, the 100ths, 1/1000ths, and so on. So as we look at those, and with what we just did, you start to realize, hey, this is just 10 to the 0, 10 to the 1, 10 squared, 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh. This is just 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, and so on. Our number system is called the decimal number system, which stands for base 10. Base 10 just means that the place values are exponents with a base of the exponent of a 10. So our number system is literally based off of the powers of 10. Now, we might get a number like 7,200,000. And it's not uncommon for us to abbreviate that by simply saying 7.2 million. But rather than saying 7.2 million, what we did is we named the first digit there as in the millions place, right? We could just say 7.2 times 10 to the 6th. The millions place is the 10 to the 6th place. This is our scientific notation. Well, that's a very good question. And in some notations you can do that, but not in scientific notation. In scientific notation, we want to have one non-zero digit before the decimal. So, and then we name the place value of that digit. So 7 is not 0, so that's the only digit we can have in front of our decimal point. So that becomes 7.2. And the 7 is in the 10 to the 6th place. That's why it's times 10 to the 6th. So you might have 380,000. So to put that into scientific notation, we've got to put the decimal point so the 3 is the only digit in front of it. So it's going to be 3.8. And what place value is that 3 in? It's in the 10 to the 5th place. So that's 3.8 times 10 to the 5th. Or you might have 0.0091. So again, to put that into scientific notation, the decimal point has to go there, because you can only have one non-zero digit in front of the decimal, so it has to be the 9. So it's going to come 9.1. What place value is the 9 in? 10 to the negative 3. So that is technically how we put numbers into scientific notation. And the key is only one digit in front of the decimal. It cannot be 0. Now, we want to find a shortcut because we don't want to have to draw out a number line like this every time we put numbers into scientific notation. So for our 380,000 here, we ended up with the decimal point here, but it started here, obviously. The decimal is always at the end of the number if it's not written in. So it had to move 1, 2, 3, 4, 5 places. Hence the power of 5 there, 10 to the 5th. We know that it's a positive 5 because this side of the decimal point is where the positive power of 10 place values are. Let's look at this one. 9.1 times 10 to the negative third. Our decimal point started out here and had to move to here. So it had to go 1, 2, 3 spaces. Hence the third in the power of 10. And we know that this is a negative 3 because this side of the decimal point is the negative power of 10 place values. So if I have 340 million, where's the decimal point right now? At the end, behind the last zero. Where do I want it to be? After the 3. So it's going to have to go 1, 2, 3, 4, 5, 6, 7, 8 places. So in scientific notation, this is 3.4 times 10, positive 8 or negative 8? Positive 8. That's a big number, right? That's the positive power of 10 place values. So let's do 39 millionths. My decimal point is obviously right here now. Where do I want it to be? Between the 3 and the 9. It has to go 1, 2, 3, 4, 5 places. This is 3.9 times 10, positive 5 or negative 5? This is a negative 5. This is a really small number. It's a number less than 1, so it's in the negative power of 10 place values. To convert the other direction, is just as easy. Is this a small number or a big number? Small number. How do you know it's a small number? Negative 6. It's telling us it's on the small side. It's after the decimal point. It's less than 1. So I'm going to take my 2.7. Have to move my decimal point 6 spaces to the left or the right? Left. I have to make this smaller. 1, 2, I have to add a 0, 3, another 0, 4, 5, 6. There's my decimal point. So that is 0.0000027. What do you think? So what if I give you 7.3 times 10 to the 5th? Big number or little number? Big number is positive 5. Decimal point has to go how many spots? 5. Right or left? Right, because it's got to be a big number. So 1, 2, I got to have 0, 3, 4, and 5. 730,000. What you think? Doable? I'm going to give you a little bit of extra homework time today because it's a bigger assignment. On page 121, it's exercise 2.4. 1 through 45, the odds go through the power of tens. Page 125, exercise 2.5. 1 through 29, the odd. And then page 130, exercise 2.6, 1 through 57, the odd, dealing with the scientific notation.